From Adage Automation and also from Siemens, who are our technology joint venture partners. As they say that, what am I here for? As they say, there is a little bit of steel in everybody's life, as they say. There is also a little bit of gas in every steel processes we have. And my job and our company and our solution is, what we do is we measure these gases. Well, I think all of us are technology stalwarts and technologists out here. We know these are not mere gases. They play a very, very important role. These gases are very rich in energy, so there's a lot of money. We need to handle and manage them very carefully. A lot of analysis of these gases gives us deep insight into our various processes of blast furnace, coke ovens, converters, etc., etc. And of course, as some of our guests have said out here, these gases also harm our environment before we throw it out of the chimney. So right from the processes beginning to the chimney, they play a very important role. And this is where we come into the picture. Right, so we're going to talk about a little bit of how we measure these gases, how efficiently we can do, what are the challenges, very quickly. But before that, let us know a little bit more, know each other a little bit, a brief of where we come from. Where, as we know, as part of the Siemens Process Analytics, we are headquartered in Karlsruhe in Germany, and you can see down over there is where locally we are located. As we said, make in India. We do this also here in India, in our factory in Mumbai. That's where I come from. Well, established in 2001, a small group of 100-odd people dedicatedly for this part of the process gas analytics and its various solutions. This is where we contribute. Well, it's a 50-50 joint venture with infrastructure being with Siemens Process Analytics Germany, with our overseas factory also in Dubai. Okay, we are ISO certified. We have also been recognized by the Honorable President of India for our contributions and services in this field. Right. The topic, as we know, is about laser analyzers, and that's how we do it efficiently for tomorrow. But before that, let us just have a look quickly about how we normally do it conventionally. Well, measuring these gases is not so easy as it looks like. And as we all know, along the processes we manufacture steel, it includes iron ores, a lot of dust, a lot of moisture, coke ovens with a lot of naphthalene, benzoyl, etc., etc. And these are major hindrances which blocks us from measuring these gases efficiently and quickly. So we do it in the blast furnace areas with our conventional systems. We do it in all the areas. We do it in the raw mill section. We do it in the above burden. We do it in the in burden. We do in the semi-clean, the clean gases, and all the areas. And these look so complicated, and that's how we do it over the years. So another very important thing we do is the CV. As I said, these are a lot of energy. We measure the calorific value of these analyzers, the blast furnace gas or the coke oven gas and the converter gases, or for example the mixed gases. And then again you see how complicated the system looks like, but they are proven. Again, for converter applications, we have a lot of the dry gas, the wet gas, and many other solutions over there. Again, as you can see, complicated systems, well proven. Another aspect which I want to draw your attention is to emission monitoring, that is the environment, as I said. So the entire ambit is over here to do the emission monitoring from all the gases we require to the dust and the SPM. Certified, very important, they need to be certified analyzers, certified by pollution local authorities, international certifications, as you can see, standardized systems, all available. But again, they look so complicated. That's how they look like. Lot of components, lot of equipments. So here we come to this juncture and we say the technology of tomorrow. So what are the challenges we have? A very common perception whenever normally we go to a steel plant particularly, or to any plant for that matter, and we talk about gas analyzers. And the first thing it says, the first thing we all try to is get rid of it if we can manage a process without them. Because they are so complicated, they are maintenance prone. And we have the challenges, we do not have efficient trained manpower as the days goes by. But on the other hand, the measurement of these gases are gaining importance day by day. So what do we do? So the innovative technology which has now come up and we are going to present to you is laser analyzers. So gone are the days right now, and soon is going to be that we forget about all those complex diagrams on which you have seen the complex components, a lot of equipments and filters and coolers, etc., which we all know. It's very simple. It's two pair of sensors, a cable, and a central electronics. That's it. So we did not have a wrong inventory of a lot of spares, the quality of the spares, etc. And by doing this, it's not only the ease of maintenance, that we meet many challenges with this. The first challenge is we measure it very, very fast. And when we measure these gases very, very fast, many of our steel processes, the people who are standing here will understand how much of contributions it can do in terms of betterment of the process or saving money. So a little bit of the technology, it's based on the laser spectroscopy. We use the near infrared ray spectrum of the bandwidth. And the advantage of this technology is, the first of the most important advantage, as I said, is time. It's very fast. The response time is 1 second, truly 1 second. Second, there is cross interference with any other gases. So when we know that we are only measuring CO or it's CO2 or oxygen, or for that matter, we only measure that and do not have to think how do we compensate internally with electronics and other stuff. So the second most important thing out there. A little bit about the technology. We'll not go much into hardcore. We can discuss about it in our several networking sessions. You can see there's a patented technology inside there which gives us the concept of lifetime calibration-free instrument. Some of our fraternity members from the instrumentation will raise their eyebrows. Is it really possible to have a lifetime calibration-free? Yes, it's possible. To have a lifetime calibration-free, we don't certify it. It's certified by certifying agencies, and that's giving immense benefit. Immense benefit in terms of maintenance, immense benefit in terms of consumables which we use of our calibration cylinders and bottles. The stability of this calibration is always a question, of the cylinders is always a question. Plants located very remote places, availability of those cylinders, huge amount of issues. Gone are those days, do not need. It's a lifetime calibration free instrument till the life of this analyzer. And that's true, and this is one of the advantages. Immense advantages. Another advantage of it is, we always talk about, are you sure you're going to really measure these gases? I have a lot of dust. I know, steel plant have a lot of dust. Are you sure I have a lot of moisture? Are you sure when you go to a coke plant, you say, my tar precipitators never work. So I'll have a lot of tar, I'll have a lot of tar fog, I'll have naphthalene, benzoyl, your system is not going to work. So don't worry, because the system which we have doesn't have any effect whatever you do with tar, with dust, and other impurities which we have. This is one of the examples which you have. You see the blue line is the measurement of oxygen, and you can see the spectral graph of dust which has gone high and in varying loads. We actually measure this in coal silos. And you have the coal silos pouring on the hoppers. We just measure across this. Almost you cannot see it from one side or the other. It's so opaque. And we measure CO and O2 as a safety parameter out there. So immense benefits which just comes with it. A little bit about the sensor pairs. I'm not going to go much into detail. We can discuss it about, but it's very simple. In fact, there is no moving parts out there, so there is no wear and tear. There is no moving parts. It's just a pair of collimating lenses and photodetectors, that's all. That's the display, very simple, user-friendly. And we have, of course, a hybrid cable, fiber optic. And this is how it looks like. So you have the sensor pairs, you can put it across your duct, your vessel, your stack, or wherever you want to. And then, of course, this electronics which I'm talking about. You can in fact have this electronics put in your own chamber if you want to, because we do not bring gases. So there is no need to make a separate analyzer room of bringing the hazard of bringing dirty gases inside or hazardous gases inside. You can even have it in X zones. Well, it is just to show you in our analytical field, we consider mass spectroscopy as one of the highest accurate way of measurement. So if you see, the blue line is about the mass spectroscopy reading, the red ones is with this laser, and they pretty much match. So very, very accurate reading out there. So just in summary, a very fast response time of 1 second, no sample components, lifetime calibration-free instrument, very, very low cost of ownership, no cross interference, and very ease of maintenance. Well, before I close the session, just to think how these come into your picture in the various steel processes. One of the very most things which people have benefited is the converters, and you know, over there the challenge is the quicker we measure these gases for CO and CO2, how much of money you can save in every blow and every heat. We have tried various experiments in conventional ways in Tata Steel in LD Converter 1, where we had tried to achieve, and we have done a lot of things. There was a big applaud that we have reduced it by 22 seconds, and we are talking of 1 second. Forget about those 22 seconds, a lot of re-engineering to be done. So, and this was the conventional graph where we can see how much of time we have saved. So there is quite a lot of value proposition is this. So, this is a big thing which we know, how fast we can measure these gases. Oxygen and cokery gases, and coke oven gases, again a big challenge, and we do it very, very efficiently. Safety application in coal silos. If you do it with the extractor, we normally do it at 15 to 22 seconds. Here we do it 1 second. So any safety, the quicker we do, the safer we are. Okay, as you can also measure the other gases in the back filters as part of the environment, as I said, and also for your monitoring of the back filters. That's it. Hope we have been able to contribute to our theme today with quality, and we'll be happy to share more thoughts with you on the sidelines and across our booth out there. Thank you very much for your patience.